Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate the orthographic projections of a straight line which happens to be inclined to the vertical plane and parallel to the horizontal plane. Now since this line, it happens to be parallel to the horizontal plane, so its projections onto the horizontal plane, that is the top view projections, will be providing us with the true length projections of this line in the top view. Similarly, because of the inclination of this line with respect to the vertical plane, its projections onto the vertical plane, that is the front view projections, they will be appearing as a foreshortened or the apparent length projections onto the vertical plane. Here we have got a straight line PQ measuring 40 millimeter, which is parallel to the horizontal plane and inclined to the vertical plane at an angle of inclination of 60 degree, and P of the line, it happens to be 25 millimeter above the horizontal plane and 10 millimeter in front of the vertical plane. Here we are required to obtain the orthographic projections of the line, that is front view, top view and left hand side view projections of this line PQ. And besides this, we are also required to locate the traces of the line with respect to the reference planes, horizontal plane as well as the vertical plane. So let us proceed with the spatial coordinate location of this particular line with respect to horizontal plane, vertical plane and the profile plane. So here we have got the horizontal plane and the vertical plane, and the intersection of the horizontal plane and the vertical plane will provide us with the XY reference line. Now this is the spatial coordinate location of the line PQ, which happens to be parallel to the horizontal plane. So we can see this line, it is parallel to the horizontal plane, and this line PQ, it is inclined to the vertical plane. Now since this line PQ, it is parallel to the horizontal plane, so its projection onto the horizontal plane will provide us with the true length projections of this line, and we have to draw the top view projections to begin with. Thereafter, we will be locating the front view projections of the line, and because of the inclination of this line with respect to the vertical plane, so the front view projections that we are going to obtain onto the vertical plane, so they will be revealing the apparent length of this particular line PQ in the front view. Now here we know that the angle of inclination of this line with respect to the vertical plane, this is equal to 60 degree. Now since this is the true length, so the angle of inclination of the true length of the line PQ with respect to VP will be marked as angle phi over here. So angle phi, it is equal to 60 degree, and the true length of the line also we have marked in the space, that is 40 millimeter. And another information we have got, that is the point P of the line PQ. It is lying at a height of 25 millimeter from the horizontal plane. That is, this distance is 25 millimeter above the horizontal plane, and the location of point P can be obtained in the space once we mark the distance of this point P from the vertical plane as well. So this distance happens to be 10 millimeter over here. So the distance of point P from HP, it is 25 millimeter, and the distance of point P with respect to the vertical plane, it is 10 millimeter in front of the vertical plane. So having located this line in the 3D space within HP and vertical plane, now we are going to obtain the orthographic projections of this line in this 3D spatial representation. So when the observer is going to look at this particular line from the top, so as we have discussed, the top view of this line PQ, it will be revealing the true length of the line because of this parallel orientation of this line PQ with respect to the horizontal plane. So since this line PQ, it is parallel to the horizontal plane, so its projection onto the horizontal plane will reveal the true length projections of this line. So this representation PQ, so this is the top view projection of this line, which happens to be the true length. Now, when the observer, it is going to look at this particular line from the front side. So we are going to obtain the front view projections of this line PQ onto the vertical plane. Now, since this line PQ happens to be inclined to the vertical plane, so its projection onto the vertical plane. So we can see point P will be projected over here at this position onto the vertical plane. So this point will be called P dash. Similarly, point Q will be projected onto the vertical plane at this position. So this point will be labeled as point Q dash over here. Now, this distance P dash Q dash we can join having obtained the locations of the point P dash and Q dash, and we will observe that this distance P dash Q dash, it will be the foreshortened length of this particular line PQ because of the inclination of this line PQ with respect to the vertical plane. So we are going to obtain the front view, which will be the foreshortened view or the apparent length projection of this line onto the vertical plane. So having obtained the front view projections to begin with and the top view projections of the line thereafter, now we need to join the points P dash and P and Q dash and Q so that we can establish the relationship between the front view projections P dash P over here and the top view projections Q dash and Q over here. So this way, by drawing these two projections, we will be able to obtain the interrelationship between point P in the front view and point P in the top view projection. Similarly, by drawing these two projections, we will be able to establish the relationship between the projections of the point Q in the front view and the top view. So having obtained the front view and the top view projections, now we are going to obtain the traces of the line. Now we know that since this line, it happens to be parallel to the horizontal plane, so no way this particular line PQ will be intersecting with the horizontal plane. So since this line PQ doesn't intersect with the horizontal plane, so we are not going to obtain a horizontal trace into this particular situation. Now this line PQ, it is inclined with respect to the vertical plane, and due to the inclination of this line with respect to the vertical plane, so we are going to get the extension of this particular line PQ to be intersecting the vertical plane at the point V dash over here. So please check, this is our line PQ. If we are going to extend this line, so we find that this line is going to intersect with respect to the vertical plane at the point V dash. And now what is vertical trace? We are going to draw the vertical projector from this point of intersection of the line with the vertical plane, that is point V dash, onto the XY reference line. So once we drop a perpendicular from point V dash up to the XY reference line, so point V will be obtained. So this point V will be again corresponding to the extension of the plan projection line when it meets the XY reference line. So this way, this distance between V dash and V, so this distance is going to provide us with the vertical trace of the line. And since we know that point P, it lies 25 millimeter above the horizontal plane, so this distance will also be equal to 25 millimeter. So the vertical trace of the line will be equal to 25 millimeter in this case. Now we are required to obtain the side view projections of this particular line PQ. So the left side view of this particular line has to be obtained. So the observer will be now looking at this particular line from the left hand side. So the projections corresponding to these 2 points P and Q, they will be obtained onto the profile plane which has been located on the right hand side. So once the observer is going to look at this particular line PQ from the left side orientation, so we can see point P will be projected onto the profile plane at this particular position. So the name of this point will be P double dash. Similarly, point Q, it will be projected onto the profile plane at this particular position. So the name of this point will be Q double dash. So having located the points P double dash and Q double dash onto the profile plane, so we can join P double dash with Q double dash. And now we can observe that since this line PQ, it happens to be inclined to the profile plane as well. And how much is the angle of inclination? This angle of inclination is 30 degree, because here you have 90 degree corresponding to this right angle triangle. So this angle with respect to VP phi is equal to 60. So the angle of inclination of this line with respect to the profile plane happens to be 30 degree. So because of the inclination of this line PQ with respect to the profile plane, so whatever length P double dash Q double dash of this projection in the side view which has been obtained, so this will also reveal the apparent length or the foreshortened length of this particular line onto the side view projections. Now we have to establish the relationship between the top view projections and the side view projection. So in order to obtain the correlation between top view projection and the side view projection, so please check these two construction lines, they need to be drawn so that we can establish relationship between point Q in the top view and point Q in the side view. Similarly, another couple of projection lines we are required to draw to establish the relationship between point P which is available with us in the top view and point P projections which are available with us in the left hand side view. Similarly, we need to establish relationship between front view projections and the side view projection. So for that, we are going to draw one construction line by extending the projection line P dash Q dash and draw another construction line by drawing the extension of the side view projection line, that is P double dash and Q double dash. So once you draw these two construction lines, so the projections of this particular line in the front view, top view and the left hand side view, they have been completed and their interrelationship, it has also been established. So having obtained the projections of the line in the front, top and side view and obtaining the traces of the line using the horizontal plane and the vertical plane, now we are going to proceed with the construction of the orthographic projections of this particular line PQ in the top view, front view and in the profile plane. So here we can see, first of all, we are required to draw the top view projections to begin with. Why we are going ahead with the construction of the top view projections to begin with? Because this line PQ, it happens to be parallel to the horizontal plane. So first of all, we are going to obtain the true length projections of this line onto the horizontal plane. That is top view projections we will be obtaining. So here we can check. We know the coordinate location of the point P. So point P is located 25 millimeter above the horizontal plane and 10 millimeter in front of the vertical plane. So this 10 millimeter in front of the vertical plane, we have drawn 10 millimeter below the XY reference line. Why? Because this horizontal plane has to be rotated in the clockwise direction. So this distance of 10 millimeter in front of the vertical plane, it will be translated to 10 millimeter distance below the XY reference line. So we have marked this distance 10 millimeter below the XY reference line, and we know that this true length of the line, which happens to be 40 millimeter. So this True length of the line PQ will be represented in the top view projections at an angle of phi is equal to 60 degree. So the angle of inclination of the true length with respect to vertical plane, it happens to be 60 degree. So with this as the starting point, we have drawn PQ length is equal to 40 millimeter at an inclination of 60 degree with respect to the vertical plane. Now having located these 2 points P and Q in the top view, so we know that the top view orthographic projection of this line, it happens to be the true length projections over here. Now we know that from the fundamentals of projections of the point, wherever point P has been located onto this vertical projector line, the projection corresponding to P dash will be located. Similarly, wherever point Q has been located onto this vertical projection line, the projection corresponding to Q dash will be located over here. So we know that the distance of the point P above the ground or above the horizontal plane, it is equal to 25 millimeter. So we know that this distance of the line above the horizontal plane or above the XY reference line, it happens to be 25 millimeter. So we have taken this distance 25 millimeter above the horizontal plane, and now since this line PQ happens to be parallel to the horizontal plane, so we are going to get P dash Q dash projection of this line in the front view 25 millimeter above the horizontal plane, and this P dash Q dash line, once we join, it will also be parallel to the XY reference line. So having obtained this projection line P dash Q dash in the front view, so we know that the front view projections of this line which are obtained on the vertical plane, they will reveal the apparent length projections of the line. Why? Because this line, it happens to be inclined to the vertical plane over here. So having obtained the true length projections in the top view and the apparent length projections in the front view, now we are going to proceed with the location of the traces. So we know that since this line, it is parallel to the horizontal plane, so it is not going to intersect with the horizontal plane. So no horizontal trace will be available in this particular situation. So we are going to evaluate the vertical trace of the line in this situation. So in order to evaluate vertical trace of the line, we can see over here, we do not have spatial location of the line PQ in the 3D projection. Rather, we have got the orthographic projection PQ of this line. So what we have to do, this is the orthographic projection of the line PQ in the top view. So what we are going to do over here, we are going to extend this orthographic projection of the line in the plan, extend it till the point it intersects with the XY reference line. So this will provide us with the location of the point V. So from point V, we will be taking a vertical projector line upwards such that it will be intersecting with the front view projection line or its extension at point V dash over here. So please check, I am going to extend this plan projector line PQ such that this extended line should be meeting the XY reference line at the point V over here, and from point V we are going to take a vertical projector upwards so that this vertical projector upwards, it should be intersecting with the elevation projection line itself or its extension. So this vertical projector does not intersect with the elevation projection line itself. So what we have to do, we have to carry out the extension of this elevation projection line and extend it up to the vertical projector which is emerging from the point V. So wherever these two construction lines, they are going to intersect with each other, we are going to obtain point V dash over here. And the moment we obtain point V dash, now the distance between points V and V dash, so this distance is going to reveal the vertical trace of the line, and this vertical trace distance will be equal to 25 millimeter. Now we are required to evaluate the side view projections of this particular line onto the profile plane. So for that, what we need to do? We need to draw two horizontal projectors through point P and through point Q, such that these two horizontal projectors, so they should be intersecting with x1 y1 reference line. So what we want to do over here, we want to translate or transfer this distance of the point P, that is distance of the point P from the vertical plane. Similarly, the distance of the point Q from the vertical plane onto the profile plane over here. So for that, we are going to construct two curved transfer lines over here. So this is transfer line number 1. This is transfer line number 2. So what we are going to do, we'll keep our needle point of the compass at the point of intersection of the reference line xy and the reference line x1 y1. So our needle of the compass will be located over here. So in the first instance, we'll open the distance of the compass as the distance between vertical plane and point P, which happens to be 10 millimeter. So we open this compass having radius 10 millimeter and draw an arc in such a way that this arc should be extended up to the XY reference line. So this way, this distance of 10 millimeter will be transferred along the profile plane. Similarly, we will open the compass in the second instance in order to transfer the distance of the point Q from the vertical plane. So we know that this is the distance of the point Q from the vertical plane. So once we have marked this distance onto the x1 y1 line, so we'll open the compass is equal to this distance. Again, draw the second transfer line arc over here and obtain a point onto the xy point. So this way, the distances of the point P and the point Q, they have been transferred on the profile plane side. And now from these 2 points, we are going to draw two vertical projectors in the upward direction so that they should be meeting the horizontal construction lines or the projector lines, which will be emerging from the points P dash and Q dash over here. So since it is a horizontal line, so the construction line corresponding to P dash and Q dash, it will be the same one over here. It will lie in the same orientation, that is at a height of 25 millimeter above the XY reference line. So here, if I extend this vertical projector line, so wherever it intersects with the horizontal construction line drawn through the point P dash, I will be obtaining the point P double dash in the left hand side view. Similarly, I will be extending this vertical projector upwards up to the locus line which is emerging from the point Q dash of the front view. So this point of intersection will reveal the point Q double dash over here. So once you obtain P double dash and Q double dash at these two locations, so we can go about joining these 2 points in the side view. So P double dash, Q double dash, it represents the apparent length projections of the line or the foreshortened projections of the line in the left hand side view. Since we are working in the first angle projections, so the left hand side view projections, they have been drawn on the right hand side of the front view projections over here. This way we have been able to evaluate true length top view projections of the line PQ, apparent length front view projections of the line PQ, and the left hand side view projections P double dash, Q double dash in the left hand side view. And besides this, we have also evaluated the traces of the line. So this is all for today. I hope that through this discussion you would have understood about the procedure of locating the line in the 3D spatial environment using horizontal plane, vertical plane and the profile plane. And you would have also understood about how do we go about construction of the orthographic projections and traces of a line which happen to be inclined to the vertical plane and parallel to the horizontal plane. So we will be continuing with further illustrative discussions regarding few more cases of the projections of the lines in the coming lectures. So thank you very much. Thanks a lot.